In the previous part of this lesson, we learned one technique to check or verify whether a function is actually a function. But when we have the graph of the function, like in this case, there is another test and a little bit easier test that we can do, which is called the vertical line test. And as the name says, all we have to do is draw a lot of vertical lines. Actually, technically, it's an infinite amount of vertical lines, but we can draw many vertical lines into this graph. And let's do it. Let's do as many as we can. And the rule is very straightforward. If there is one of these vertical lines that touches or crosses the graph at more than one point, then this is not a function. So let's review this. All of these lines only cross or touch the graph at one point. They do not do it at more than one point, only one. That means, yes, this graph represents a function. But let's do a second example. Now let's make this graph. Looks a little bit more complex. Well, let's one more time, let's do our vertical lines. And we have to make as many vertical lines as possible. And now we start checking. This first one touches the graph at two different points. That right away is not good. That right away tells us it's not a function, but let's keep looking. This one only once, twice again. Another problem. This another twice. So more problems. We have three lines that are touching the graph at more than one point. Only one line doing it is more than enough. But here we have three. So that's enough evidence to say this graph simply doesn't represent a function. Now that we learned how to verify whether a function is or a graph is actually a function, let's talk about the other two names we give to the input and the output, because every function has two types of variables, dependent and independent variables. Let's bring this function y equals 2x plus 1, and let's bring our set of numbers of x and y. X represents the input, y represents the output. And let's bring our calculations rectangle, our calculations board. Let's first put an input of -2. This means we're going to replace the x for a -2 into our function. So if we put in our calculations rectangle, 2 times -2 plus 1. 2 times -2 is -4, and -4 plus 1 is -3. So as we put an input of -2, we get an output of -3. Now let's try an input of 0. So one more time, we just replace the x for a 0. And now we have 2 times 0 plus 1. 2 times 0 is 0, plus 1 is 1. So an input of 0 gives us an output of 1. And finally, let's do one more, an input of 4. So we're going to replace the x for a 4 into our equation, or plug in the 4 into our equation. So 2 times 4 plus 1. 2 times 4 is 8, plus 1 equals 9. Now that we have this set of numbers and we find this relationship, what we can see is that as we change the input, as we try different numbers in the input, the output is also changing. So depending on the input, we get an output. That means the input is what we call the independent variable, because it doesn't depend on anything. The x is any number we can try to plug in to this function. That's why it's independent. And the output, or the y, is the dependent variable, because the y, or the output, is dependent on whatever value of x we are plugging in. So x is the independent variable, and y is the dependent variable. Finally, to finish this lesson of Intro to Functions, let's learn about the function notation, because from now on, especially on this unit, we're going to be using this function notation. We are used to see equations as y equals something with x. But in functions, instead of writing y, even though it's the same thing, it represents the same, it represents a y coordinate, or especially when we're graphing it, we write it as f of x, which is the function notation. The reason why we do this is because f represents a function, is telling us this is a function, and the x in the parentheses is saying that this function is with respect to x. So whatever function it is, let's say this function is to calculate velocities, to calculate weight, to calculate payment, cost, anything. And the letter inside of the parenthesis is telling us what's the variable that this function is dependent on. In this case, the function is dependent to x, but if it is a cost function, it might be dependent on time, depending on units, depending on money. Well, but let's put this into practice. Let's put this into work. How does this function notation works? Well, if you put f of -2 in the parentheses, like in this case, it means we're going to replace the x for a -2. But let's do another example. This one a little bit slower. We have f of 0. The 0 is inside of the parentheses. So that means we're replacing the x for a 0. 2 times 0 plus 1, we get 1. And then let's put f of 4. The 4 is inside of the parentheses, which means we're replacing the x. So basically, whatever we put in the parentheses is what's going to replace all the x's into the function. So that's why we have 2 times 4 plus 1. And 2 times 4 plus 1 is 9. So as we can see, these are the same answers that we got in the previous slides, because this is a function.